Hi everyone. So my name is Ban, and today I will talk about Jetpack Compose and what is happening under the hood. I mean, we won't go really deep into it, but we'll scratch the surface behind it. So before we start, just a little bit about myself and my experience. Overall, around 5 years of experience in Android development. So for the last 8 months, I'm working with Jetpack Compose on building our Montenegro's e-wallet ProfitApp. And yeah, I started with Java and Butterknife, if anyone knows about those. I switched a couple of architectures from MVP to MVVM to MVI. Luckily for async communication, I skipped async tasks, so I moved directly to Eric's Java live data and coroutines, and maybe the final step that is showing the most how much Android changed in these 5 years is reference to the UI components and stuff changing it. So you start with find UI ID, then we went to Butterknife, which was crazy big deal at that time. Then we moved to Kotlin synthetics, which was deprecated, then view binding, and now Jetpack Compose. There is also data binding between view binding and Jetpack Compose, but yeah, it's too much. So, okay, let's look at the agenda. So my concept of today's topic is going to be take a look into current Android view system, like what is happening behind. Then we will talk about Jetpack Compose in general. Some key concepts like imperative versus declarative programming paradigm, which is a bit of a change if you come from Android view system. Custom UI components, how they are done into Android view system and Jetpack Compose. Then finally we are going to take a look into the composable annotation, which makes a lot of magic behind everything, because you will see that we don't use classes for views, we now use functions, Kotlin functions, which is crazy. And at last I will talk about modifiers, which are parameters in composables that make them really flexible and nice to work with. Okay. So Android view system. So I guess most of you know how Android view system works essentially. So this is the really simple example of one screen that shows only like hello world at the screen. So we are using XML for writing our UI, which XML is basically markup language that enables us to write some human readable structure trees for our UI components. And yeah, like the main building blocks of XMLs are views and view groups. So the main difference is basically the views are really the UI components that are rendered, like text view, edit text, and checkboxes and stuff like that. While on the other hand, we have view groups that basically represents the collections of those views, and they are showing them where should they be put on the screen, the position and the size and everything. So like the magic about these things, like these are all XML tags, relative layout, text view. So basically what is happening behind is these are all like Java classes that essentially extends the view class. And if you see this fun, I would say, fact that view has around 30,000 lines of code. So it's a bit complex, you can say. Yeah, so whenever we want to make custom components or something like that, we are essentially extending the view class, which is responsible for writing, drawing the UI on the screen. And of course, XML is all static. When we define these values, everything is static. If you really want to change the values and stuff in the runtime while the application is running, we are doing that through activity and fragment using Kotlin or Java. So my bigger question here was, like, how do we end up from this XML file to the actual screen that is that has rendered the hello world text? Like, as you can see, these are all just some XML tags. I mentioned before that text view is a class that extends essentially the view. Well, basically text view also has some kind of help there, because it also contains the layout part. There is a couple of layout types for texts, but for this example, the simplest one is the static layout, which is the whole purpose of it is to basically to draw the text, one line of text that is static and won't be changed dynamically. And in that static layout, it is also responsible for making everything about calculating the measurement and fonts and stuff like that. So basically, those all information, it is passed to Canvas. And in Canvas, luckily, we have a draw text function that is taking all these parameters and then does its own magic. So just wanted to make sure that we have at least some kind of picture regarding how the current Android view system works behind the scene. So yeah, now I want to talk a bit about Jetpack Compose. First, maybe one question, like how many of you did hear about Jetpack Compose? Can you raise hands? How many of you tried? Okay, it's a decent amount of people. So yeah, basically Jetpack Compose is a new UI toolkit of Androids. We are moving away from XML. It brings new like philosophy that says like UI as a code, which is quite nice if you think about it, because the whole purpose is to write the whole UI inside Kotlin. Like you don't have to learn any other markup language like XML and stuff like that. And the really cool part is that you can use Kotlin Kotlin features like statements and the loops and stuff like that. So yeah, now if you think about, maybe the question arises like why you should learn one more toolkit technology API, like Android is moving every year, changing those things. Well, basically the real reason why they try to update the new view system and everything is because the Android SDK is old, around 13 years. So if you think about like the apps from 13 years ago, like they are much simpler and I don't know, not so nice looking. So the design in these 13 years really upgraded and it's much nicer, smoother. You have a lot of effects, animation and stuff like this. So when people were working on Android SDK 13 years ago, they didn't think about all those cool features and stuff like that. Essentially, they try to keep it in touch with the requirements of designers and stuff, but I think that at one moment they just figure out, let's just do it all over again. So yeah, that's maybe not such a bad reason to move it. One big reason, one big change from XML to Jetpack Compose is that we are quite used to imperative programming paradigm, and the Jetpack Compose is actually like really full into declarative one. So I just wanted to mention a couple of differences. So basically, imperative way of approach of working is that you always want to describe like every step of the UI state change, for example. Like you will go one step, okay, hide this, show this, disable this, like you're going every step like we used to. But on the other hand, we have declarative that is basically the whole purpose of it is to, when you are reading the code that is already written, like everything is described in that code. You don't have to look into the logic and stuff. I mean, the whole logic is behind it, but it's much more readable and intuitive. It requires a bit more code, but yeah, we will see in the example. And the biggest drawback for imperative approach is you always have to pay attention to your old state of the app. So if something has changed, you need to think about, okay, what was happening before this? So I need to update my changes like this, and then move with my own changes. So we'll see in this really simple example. So we have just a small screen with a couple of friends. In some cases, sometimes we don't have friends, so we have empty state there. So imperative way of working in this example would probably be when you get the list of friends, you would call something like update friends results, or it's probably bad name, but no worries. And then you will probably check, okay, friends list is empty. I'm going to show my empty state. If not, I mean, we will continue. Then we will hide the empty state just in case if before it was open, and then we are going to update our recycle view with the list. On the other hand, declarative way and composables works like this. You make a custom composable, you pass it friends, okay, show me the friends, and you have an additional parameter that says show empty state, and you pass it the check, which is friends dot is empty. So if you think about it, this is much more readable, I would say. But of course, we don't want to forget about what is happening behind this friends composable. So of course we need to set everything set up. Like we need essentially to have the check if we really want to show the empty state or the friends list. Now in this example, it's pretty cool to see like how composable works with Kotlin, because everything is synced up, and you can just say if draw me this composable, else draw me this one. So that is much more productive way of working, in my opinion. So these are the imperative and declarative way of programming. I hope you understood at least some of it. And now there is another big change between composables, Jetpack Compose and Android View system, and those are like custom UI components. Of course, every project has a bunch of them. Designers are going crazy with their ideas, and we need to fulfill them, right? If you think about custom views, these are probably the steps you need to follow if you want to make any custom view. So we're basically going to implement some XML file to put some tags that you want. Then you are going to create a custom view class that extends the view or view group depending on what you want to achieve. Then if you really want to have some values inside it, you need to define attributes. Then put the values of these attributes into the views from the XML. And at the end, you probably want to make some setter functions to enable change of that custom view programmatically inside your code. On the other hand, we have custom composables, which are basically, like I said, they are Kotlin functions that have this annotation composable, and you define parameters you want to show, you put them where you want, and basically that's it. I mean, this is really simple example, maybe not the best, but in case you want to create some custom text view that always attaches the hello string in front of your value, the name or whatever you want to pass it, like just think about it, how much code would you need for the custom view for simple things like this, and we achieve this in 4 lines of code, where one is annotation and the other is column. One of the bigger changes here, maybe it is not shown the best, but custom views always extend some kind of view or view group. So you always have one parent class that you take the behavior and stuff and you modify it and change it and stuff like that, but you are always limited to that one view that you are extending. On the other hand, with composables, these are functions, these are not classes, we cannot extend anything. So the main purpose is composition, like building blocks with Lego. If you think about it, you just put one next to each other and you pass things you want inside your composable, and you want to show what you want to show. So that is also a bigger change for myself when I transfer to Jetpack Compose, like thinking about, okay, I cannot extend the behavior of some custom view or whatever, and I cannot modify it. So, I mean, it needs some time so you can get used to, but it's, at the end, I think it's much simpler and you can achieve almost more, at least, I mean, more things than with custom views. Okay, so now I hope you get a bit of grasp regarding Jetpack Compose and some of the differences between Android view system and composables. What is happening actually with this composable annotation? Like I said, these are functions, these are not classes that are extending some views that are drawn into the canvas and etc. Like these are Kotlin functions. So, first of all, composable functions are basically domain-specific language, which means they are really used only for this kind of purpose. So they are using app data and rendering it into the screen, which basically means that they need their own context. Like we'll show you later a bit. If you wonder if you need a special annotation processor, you don't, because Compose actually extends the Kotlin compiler plugin that is basically done during the compile time of your app, and everything that is done in that period of time. So during the compile time, Kotlin compiler plugin uses the composable functions and compiles them into the things they understand. If you think about it, they are also quite similar to suspend functions, because as you may know, suspend functions are used for async things to be done, and these are all just language keywords, essentially. So what is common with those two is that suspend functions and composable functions cannot be called from anywhere inside your code. You cannot call suspend function from the main thread. You have to have some coroutine scope or call it from another suspend function. Same things go with composable. So composable functions only can be called from composable function. And if you remembered in the first example of main activity Jetpack Compose, we had some set content function that basically enables behind the scene, of course, context for composable functions, which is called composer. Okay, so what is composer? What is this context? Like, why do we actually need this context? Is that each composable behind the scenes receives that context, composer, and passes it to another composable functions. The same goes with suspend functions. And why is it so important in everything like this? Well, one of the main features of Composer is that it contains the data structure that is similar to gap buffer. I don't know about gap buffer, but it is quite simple actually. So it's basically the collection, as you can see on the right side, with the cursor or pointer at the top of this empty collection. And this big empty space is called gap. So that's the name gap buffer. So why do we need this? Well, again, I will repeat myself. Composable functions are not classes. They cannot be, they don't extend canvas, they don't have draw things inside them and stuff like that. So they are basically used for emitting their state to the gap buffer. So gap buffer is basically used for holding all the state, and it will use that data to then render on the screen. So first thing you do, I mean, when app is run, you go through all your composables in your screen, in your first screen, and when you call those composables, they are basically filling the data inside this gap buffer. So we had some 3 composables, and we put the data inside the gap buffer. This process is called composition, and it's important later on to figure out what are the phases of the drawing and stuff. When we want to re-render these composables, when we want to change something, then we will need to go from the top. Yes, the pointer goes at the top, then goes again through all the composables and checks which one is changed. The one that is changed, it will get updated, the others will be just skipped. Now you may wonder, what if we dynamically change our screen? What if we add new composable between the second one and the third one? Well, this is where gap buffer comes handy. He basically takes the big chunk of empty space, the gap, puts it on the place where there is another composable that needs to be saved, and then it inserts that composable, the triangle, blue one. And that is essentially how Composer, so the composable context, works, and it holds the whole data, UI data, that we are writing in our own Kotlin functions, composable functions. So how does this help us? Well, essentially, Jetpack Compose has 3 phases for drawing all these kind of UI elements and stuff. The first one is composition, the one we talked about, where we go through all the composable functions and we put that state into our gap buffer. So that is his whole idea. Then we have the second one, when we put whole state inside gap buffer. Then we are on the second phase, which is called layout, which basically it's something similar to the static layout at the beginning. We talked about text views and stuff like that. The whole purpose is to measure things and see where should they place it in the 2D coordinates, of course. So it gets the idea, okay, this is the screen, this is how it should look, and after everything is calculated, measured, it passes to the drawing state, which takes everything and draws it on the canvas. So that is like the whole idea behind the composable functions and annotation. The last part I wanted to talk about is modifiers, because for me they are so great. Like, they are making my life really easier a lot, day by day. I'm grateful every day for using them. So modifier is basically a parameter that you can inject into any composable you are using. So it basically configures the look and the behavior of the composable. So the background thing of any component, like text, checkboxes, or whatever, you have total control behind it, because you will see you have the access to the canvas, and there is plenty of built-in functions that you can use for your sake. One also important thing is, if you see in this example where we have box, which is basically like a regular view in Android view system, we have the modifier that sets the size and the borders. Like, imagine how difficult would this be to build inside Android view system. I mean, for me it's silly how some trivial thing is so complicated that you need drawables, separate drawables, and stuff like that. So you have a lot of these, like borders, rounding edges, shadows, and stuff like that inside your modifier. And as you can see, they are basically ordered collection of modifier elements. So each of these settings are basically modifier elements: size, border, or any other. Why is the focus on ordered? Because you will see how important is how you set up your modifiers. So this is a new example, which is almost the same. We have size, we have background to color black. Okay, we rendered our square. On the other side, we extended our modifiers. We put our paddings and the background to red. So we have two backgrounds. We have black one and the red one. But before the red one, we have set the paddings to 10 dp, which basically makes now our content smaller, or canvas. And we have that smaller canvas where we are going to set up background to the red. If this is not explained well, we have third example where we have new padding and new background with color gray, and the same thing happens. After the second padding, we have much more smaller canvas, and we set the background color to gray, and it is drawn like this. And the thing is that you can do this on every composable function, on text, checkbox, whatever. One more really powerful thing about modifier is essentially you have the option for draw behind that basically lets you use the canvas API for the whole canvas that this composable is taking. So if we have size of 150, we set draw behind. We basically have a square and we can draw whatever we like. In this example, we draw a rect, which is, you have a lot more built-in options like drawing circles, lines, and I don't know what. And you can see, after the modifier, you continue with the regular text. So you set the text, the color, and this is what you get. It's not the nicest, but it shows the powerful stuff about modifier. So he gives you the option for you to access the canvas behind your views, I can say. One more thing I wanted to look like before the end is modifier.border. Like, why is it so simple? Like, why didn't Android view system use it before? Well, basically, so these modifier elements that we are training one after the other, they are done with this function modifier.then. So if you want to make some custom modifier, you are going to override the then function with code you like. So in this example, we see some built-in draw with cache modifier element, and inside it, after who knows how many lines of code, we have draw rect border. And now the border is drawn with the information that is given to him regarding the width, color, or whatever you like. So basically that's it. Like, my whole goal was to introduce you to Jetpack Compose, maybe look something underneath it, how it works. Also a bit inspire you to move to Jetpack Compose because I think it's much more productive. I mean, it's still young. I think it covers most of the use cases. There are still a couple of things that are not developed, and maybe it's easier to use the Android view system, but for the most applications, I still think it's pretty much ready. But those are my personal thoughts. So yeah, thank you. If you have any questions. Thank you.